Hello, everybody. I think we're live. Let me check that. Yes, we're live. So, hello, everybody. Welcome to today's event with Nick from ENS and myself, Adrian from OpenZeppelin, where we're going to discuss DAOs and how OpenZeppelin can help you and can help ENS uh, build a better community. Nick, do you want to present yourself first for the few watchers that may not know you? Maybe we want to wait a few minutes before we start.
Sounds good.
Yeah, let's wait 3 minutes. So while we wait to start, just a reminder to everybody that there is a link for you to ask questions. We'll have a Q&A during this talk, during the last part of this talk. So feel free to ask your questions. I'm guessing this is mostly about what we're here to discuss today. So ENS and Governor and DAOs in general. But maybe if you have more broader OpenZeppelin question or ENS, we may have some time to ask them. So you could also ask those questions. Also, stay until the end. There is a POAP token for you to claim if you're attending this live workshop, and hopefully we won't be bothering you too much during the talk until you get the POAP. So I think we're 3 minutes past the hour. I think we should start. Nick, do you want to present yourself?
Certainly. I'm Nick Johnson, creator and lead developer of ENS, the Ethereum name service. We, as everybody I'm sure is aware, recently launched a DAO, and we used OpenZeppelin's contracts to do it. And so I'm here to talk a bit about why we chose OpenZeppelin and how it was useful.
Okay, and so myself, I'm Adrian. I work as a developer on the contract team at OpenZeppelin. I obviously work on this at this governor contract, but also on the maintenance of all our open source contract that ENS has been also you've been using even before for that. I think if maybe I'm wrong about that, but a
Oh,
lot
you're
of
right.
projects are using.
Yep.
Yeah, I mean it's a go-to place for a lot of smart contract developers. I mean, don't try to reinvent the wheel. I mean, there is already a lot of business logic that you want to get on chain, so you don't want to have to do ERC20, ERC721 on top of that. And no, it's the same goal that we're going to achieve, hopefully, with governors is help people by leveraging the biggest part of the code so you can focus on your business logic. Uh, Richie, can we get the slide? Yes, thank you very much. So let's just start with a quick presentation from OpenZeppelin. I'm sure most of you are here for the ENS part, so we'll have that just after. But just a quick presentation of governance with OpenZeppelin. And the idea is that we work on adding this contract over the past few months to basically help you improve your governance for your application. And ENS is obviously taking this code just to the letter. OpenZeppelin, our mission is for those of you who don't know us already, our mission is to protect the open economy. So this includes all of DeFi, a lot of partners out there, but also more fundamental application like ENS. Uh, we do that through a set of products and services we have. It includes obviously the OpenZeppelin smart contract, which I work on, but also the audit part and the defender part. And the idea here is to have a complete set of tools for all applications, developers, and application managers out there. So you can start with our contracts to easily deploy your first application on chain. Obviously, audit it before you get it deployed. That's always better. So we have our audit team for that. And then Defender, which is another product that is part of the product team with contract. And Defender is more about managing it. So if you want to do any updates on your application, do any maintenance, and this could include obviously triggering like maintenance call and upgrade calls through a governor contract. So we have that set for you. And this includes support for multisigs, for time lock, no, for governance. So it's basically the place to go when you want to schedule big maintenance operation, or just if you want to have your application be very reactive with our sentinels. So the big question here today is, what is governance? And I'm sure Nick will have his own definition of governance, but here we have a brief view at Wikipedia's definition of governance. And basically it's saying that it's also process and interaction, the social construct, the governance, the state, the market, all the networks effect that allows a group of people to organize and to interact. And so you could say that governance is part of our state or legislation, maybe your city councils, your schools, organization, all that kind of thing. But in the Web3 world, in the decentralized world, it's also how decisions get taken on how protocols are going to evolve. And there are multiple ways governance can form in Web3, and mostly I will describe them in two categories, which would be off-chain governance and on-chain governance. And the off-chain part is mostly people like giving their opinion, discussing things, but in the end, the actual decision being taken on chain is mostly governed by one person or a small group of persons through a multisig. And this is things that can be very effective, that can be organized through things like Civil or just like through Twitter polls or anything you want. You can just ask people for their opinion. With Civil, you can go a bit further and have snapshots of possibly tokens or assets that some people have on chain considered, but those are non-binding. Like if the manager of the application doesn't agree with what's being done, it basically can decide not to enforce it. And I think that's how ENS has been working so far with a multisig of people from the ENS Foundation that were obviously listening to members of the community through workshop, but they want to put it to the next level. And the next level is on-chain governance. And this is different in the sense that it's no longer an EOA or a multisig that is in charge of the decision of the platform that is privileged. It's a governor contract. And this means that any decision that the community takes needs to be validated by this contract, this governor contract. And this is much stronger because for anything to pass through, it has to be approved, there has to be a vote. It's much more binding. And this means that maybe it can possibly be slower to react in terms of crisis, but it's also much safer in the sense that the community is in control, the community is in charge, and admins cannot take over the system very easily. I mean, maybe they could if they have enough token, enough voting power, but in most cases, like it would not be the case, and the community would be in charge. And this is a model that has been used by many projects, including Compound. Compound has a governor contract that has been very successful and that has been deployed many times. And here is an example of a proposal for it might be compound, but I'm not 100% sure of that. I mean, it's the viewing of a proposal vote from the Tally website. And Tally is, I mean, we'll discuss Tally later, I guess. I will rephrase. Those are also people that we've been working with building this contract. Tally is a project that provides UI to easily be able to to monitor the votes that you care about, the governor that you care about, and be able to vote on that. And here you see who voted on what, and how this proposal was in fact successful. And the governor by compound has been extensively reused in the community. And I think last time I counted, there were over 80 instances. Maybe there are more today. And I basically built a subgraph to start indexing them all and see what was happening on chain. And what I was very surprised by is the sheer number of governor that exists on mainnet. Some of them are copies, some of them are bad deployment. Maybe people should test more before they deploy to mainnet, I guess. But I mean, in the end, a lot are very useful and have been used by communities. But compound governor, despite it being like very successful, has not been designed for this kind of reuse. It was a compound project, and a lot of people have taken the code, copied it. That's one of the strengths of Web3, and sometimes they modified it, and that's where it starts being difficult for this entire space, is that we have a lot of governors that are very different from one another sometimes, and it's very difficult sometimes to know how to interact with them. Sometimes events are not exactly the same, so you don't catch them very effectively, which is bad if you try to build, for example, a subgraph. Sometimes argument of functions are different, which can be very bad if you send the wrong values by mistake. So the idea with OpenZeppelin was saying like, hey, this is obviously something that people need. Maybe we can build that better by making it more modular and like build it in a way that we know people will be able to extend on. And this is something we introduced with version 4.3 of our contract lately. It was a few months ago, and we introduced a governor, like really the core of the contract, but also a set of extensions. And just like our other contract, this was designed in a way that it can be modular, it can be extended. Like for example, with our ERC20, you can add mechanisms like total supply, or like I don't know, ERC, like the permit mechanisms that is really useful for a transaction. For 721, you could add like URI storage or other like posability modules. Well, we try to design the governor in the same way. And this means that it's not just a contract, it's an entire system in the end. Because the governor itself wants it to be modular, but we also need a token to obviously feed on this governor to provide like voting number. And right now we are supporting the compound token as well as the OpenZeppelin tokens for the ERC20 flavor, and we're working on voting with NFTs. So that's something that should be coming up in the next few weeks. And also our governor is able to interact with time locks, either the OpenZeppelin time lock or the compound time lock that you may have deployed already. And so it's really a big system, because if you already have a comp token deployed, or if you already have a comp time lock deployed, where you are able to put our governor in the middle and configure it with the right module so that it's aware of its environment and it works well with whatever token you have, whatever time lock you have, whatever model you have. And if you want to alter some of the mechanism of the governor, hopefully it will be very easy for you to just build a small module and add it on top of code that has been reviewed and is trusted by the community, rather than having to edit this code and potentially mess something up, or you need to go to an audit to review everything again, and that would be messy as well. So it's really a system. And on top of this token, governor, and time lock system, there is also a lot of tooling. There is Defender, proposed by OpenZeppelin, that's going to help you possibly schedule mechanism, like maintenance operation through the governor. There is Tally, that is more going to be facing the community to help user vote, help user review. And we also have a subgraphs ready to be able to index your activity on your governor, so that if you want to have stats or have a structured view of what's happening, this is also a solution for you. Talking about the modularity and the modules, right now we have quite a lot of module already. We have the voting module that's basically saying that who is able to vote with what power. So this is what's going to bind your governor with your token. Could be a compound token, an OpenZeppelin token. Maybe in the future, other things. We want to experiment with 721, 1155, but it could be, you could basically create a voting module to connect to any reputation system, maybe proof of humanity or things like that. Then there is the counting module, and the counting module just says how those votes are aggregated. Maybe you just want to have for and against. Maybe you want to add abstention as a way to count the vote. Maybe you want to do quadratic voting. You can customize that through the counting module. There is obviously the time lock module, so there are a few of those so that you are able to connect your governor to a time lock. By default, the time lock is going to just execute proposal on its own, but with a time lock module, you are able to connect your governor to a time lock so that all proposals are scheduled through a time lock, which adds delay for security purposes. We have compatibility extension with Bravo. We have settings, which is a module that allows you to update some of the settings of the governor through governor actions, some kind of introspection. And we have upcoming modules. There is a prevent late quorum mechanism that we've been working on, that's currently in the master branch on GitHub, and that's waiting for the next release. And we have additional modules in the pipeline, like the counting module, score counting module, which is basically saying that rather than saying yes, no abstention, you would basically be able to put a grade on each proposal. So that would give you more expressivity on how you can say I'm against, I'm for. For example, if you are getting delegated out of votes by a community, maybe you want to have a more subtle vote than just I agree or I disagree. Maybe you want to say that my community agrees at 67% or something like that. So all those modules might sound complicated. Hopefully we have the contract wizard. If you don't know the contract wizard, I encourage you to go and check it out. It's wizard.openzeppelin.com. It will help you build any of our contracts and assemble the module. This is available for ERC20, ERC721, ERC1155, so the three biggest token flavors. But lately it's been available for governor as well. So you are able to customize your governor, enable module, disable module, and it will basically provide you code that is good to go. You should obviously check it, run it on test nets, possibly go through audits before you use it, but it should be mostly good to go. So this is really the way to start if you're not really sure how to assemble a contract using our many modules. As I said, OpenZeppelin Governor is also supported by our OpenZeppelin subgraph package, which is basically a toolbox for building subgraphs. And since our OpenZeppelin Governor is very similar to Compound, I mean, we designed it to be mostly compatible with Compound. This means that the subgraph package we have for the OpenZeppelin Governor actually also works for the Compound Governor. So you could also be indexing Compound governor activity using OpenZeppelin subgraph. Like, it's really a big toolbox, and we want as much intercompatibility as we can in this ecosystem. So here are the most relevant links. OpenZeppelin contract, this is the main package for the contract. So we also have an upgradable version. You will find all that described in the docs. Obviously, we have the docs, also the forum where you can ask questions to the community, and Defender, which you may want to check out. That's it for me. I think we can go to Nick. Again, I want to remind you, there is a link. Hopefully, maybe it will be shared in the chat. There is a link for you to ask your questions so that we can answer them later in the Q&A.
Nick, you're on mute.
Well, that's embarrassing. Hello, everyone. Thank you, Hadrian, for the overview of OpenZeppelin's governance features. I'm Nick Johnson, here to talk a little bit about ENS, a little bit about the launch of the DAO, and also about how we decided what governance mechanism to go with and why it was OpenZeppelin. First of all, I won't dwell on this too long, since I expect most people by now are pretty familiar with ENS. But what is it, and why do we have it? Its main purpose is to turn machine-readable identifiers like Ethereum addresses into human-readable identifiers, ENS names. It goes beyond just naming contracts and accounts. You can name content such as IPFS sites and so forth. Decentralized identity via primary ENS names. So when you log into Uniswap, you see your ENS name in the corner instead of your Ethereum address. And a great deal beyond that, which is, I guess, out of scope of this particular talk. So what is ENS at the technical level? ENS is a hierarchical naming service. So we have a root, which represents the sort of the entire tree of ENS names. And under that root, we have top level domains like .eth. And then under that, we have second level domains like Inigo Montoya and MetaMask and Oracleize and Nick.eth and so on and so forth. And you can create subdomains of those and so on recursively. And all of this is implemented internally using the ENS registry, which is the sort of a central phone book sort of directory lookup of from ENS names at any level in the tree to who owns them and which contract is responsible for resolving them. And then the resolvers are individual smart contracts. We have standard ones provided, but anyone can write a resolver, and their job is to translate from an ENS name into whatever resource the user is looking up. So resolving a name is a two-step process. First, the user consults the registry, saying what's the resolver for foo.eth, and it responds with the address of the resolver, and then they consult the resolver, and it responds with whatever piece of information they were looking up in the first place. The final component of ENS that's relevant here is registrars, and a registrar is basically just a smart contract that owns a name. So .eth is owned by a smart contract, and that contract has rules on how it will issue subdomains of .eth, what you think of as ENS names, nick.eth and so forth, and how they can be renewed and reassigned and transferred and so forth. What is ENS from a social point of view? Because both of these things are kind of relevant to how we decide to govern ENS. First of all, we see ENS as a public good. We're not attempting to build a system here that is extractive and for profit. We believe that ENS is basic infrastructure and that it should be run as a public good with anyone able to have input into how it's run and people benefiting from the good things it creates sort of impartially. We prioritize use over speculation, so we're not interested in being a speculative resource where people buy names and resell them at a profit. Of course, people will naturally try to do that, and we're not trying to attempt to stop them doing it. But when we design our system, we're thinking about how we can build it to be the most useful to people who actually want to put ENS names to use. And a corollary of that is the principle of least surprise. So if you see that there is a nick.eth, it should ideally be somebody called Nick. If you see OpenZeppelin.eth, ideally it should belong to OpenZeppelin. The intuitive, obvious answer wherever possible should be the real one. And we need to balance that against the importance of stability and sovereignty. So if somebody other than OpenZeppelin has OpenZeppelin.eth, we shouldn't take it off them, but we should build a system where it's not profitable to sit on that name and deny the use of it to the people who actually want to use it. So all of this leads into the question of why do we even need governance in the first place? And ENS's goal is definitely to minimize governance. We don't see the value in making the system arbitrarily upgradable, but rather with identifying areas where it's important for upgrades or changes to be supported and facilitating those in a way that sort of minimizes the level of trust people have to put in the system and the uncertainty and the risk. And the thing is that we're humans. We're never going to be able to design and build a perfect system on the first try. So there are going to be bugs. There are going to be upgrades and improvements we come up with that weren't obvious from the start. And there are going to be changes outside our control. So some of the things that need manual control, we've got the ENS root, which is that empty name that controls all of the top level domains. And that allows the creation and replacement and upgrade of individual top level domains like .eth and all of the DNS integrated names. Actually, now the root no longer has control over .eth because we have a mechanism that allows locking out individual top level domains so they can no longer be changed, and that's been applied to .eth. So even the root key holders were unable to make any changes to the .eth domain. And then we have the .eth registrar and controller. So they control how names are registered, transferred, renewed, etc., what the fees are for those, and so forth. And those are, as of recently, have been transferred to the DAO. And you may wonder why those have to be affected, but why human control has to be provided over those. And one reason is for eventual upgrades and improvements. We're actually planning some of those at the moment. Another is that registration fees have to be set at some level, and that potentially needs adjusting over time. And a corollary of that is that we rely on an external oracle for the US dollar ETH price in order to charge the right amount. And oracles have a tendency to change over time and require upgrades to their interfaces or transition to a new provider, things like that. We've got the DNS integration, which is where you can use any DNS name inside ENS. And that also requires some control over the root in order to be able to upgrade that to support new DNS ciphers and so forth, to support new DNS root keys when they're upgraded, all these sort of things. I mentioned pricing and parameters, and the other one is the reverse namespace. So if you have a primary ENS name set so that when you log into your app, you see it listed, then you will that all of that is managed through another namespace of ENS, and there's the potential to need to upgrade that as well over time. So a short overview of what we decided to do with ENS when we launched a DAO. We minted 100 million tokens. The 50 million of those go to the DAO itself so that they can be used for future purposes in helping the DAO achieve its mission. 25 million went to contributors. That's over 100 individuals who contributed to ENS's development in some way over the last 4 years. And 25 million went to users in an airdrop. The airdrop was based on per account, not per name, because we believed that we wanted to create a distribution that favored real use in people over squatting and speculation. And so we did our best to identify factors that meant somebody was truly invested in ENS in the sense that they believed in its success. So we based it on the length of ownership, how long you'd owned a name for already, and how far into the future you've registered the name for. And the purpose of ENS tokens here is that they're voting weight for adjusting things like we went through earlier, the parameters of ENS's functionality and upgrades and so forth, and also to vote on how to put the treasury funds to use. ENS is a public good, as I already mentioned, and we wanted to be able to fund other public goods and other efforts inside the ENS and the wider Ethereum ecosystem, rather than just sit there accumulating, doing no one any good. So we've established the need for governance. The next question was how we go about it. So we believe that having a stable naming layer is crucial, and it's something we can't really afford to take risks with. Security is paramount. So the approach that a lot of DAOs take, where DAO token holders vote on something like Snapshot, and then the key holders of the multisig that actually controls the resource promise to enforce it, was a non-starter for us. We think a little extra overhead on the on-chain voting is worth it in order to have the guarantee of security that votes will be honoured. You can't rage quit a namespace. So, unlike some systems that are primarily concerned with funding things, you can't take your ball and leave because it's important that there be a single unified namespace that everybody uses that resolves to the same thing for everybody. So we can't use a Moloch style DAO either in this application. And finally, the instinct for us is that it's money is not as important as people. So in short, we would rather trust the DAO with the treasury and find that it was misallocated than have it take control of, say, the ENS root immediately and then do something destructive with that. We think that the people who use ENS and the things they do with it, preserving the stability of that, is more important than worrying about what happens to the treasury. Not that we should be careless, but that we should consider the system itself is the most important thing to protect. So our starting point after all these considerations was a compound style DAO. Compound, built Governor Alpha and Governor Bravo. They're very straightforward and robust on-chain voting mechanisms. And so we have a sort of a laundry list of requirements. It needs to be well tested and mature. It needs to be modular and upgradable. It needs to be able to be customized for our needs and widely integrated into tools such as Tally and Snapshot and so forth. And we found that, while Compound itself met some of these requirements, deployments of it were often ad hoc. We'd be looking at, Gitcoin used a fork of Uniswap, which used a fork of Compound. And although the original contracts were well tested, who knows what changes have been made along the way. And we were looking at substantial work just to establish even a safe starting point. Even setting that aside, the contracts weren't built with modularity and extensibility in mind. So finding that OpenZeppelin had taken the principles of the Compound DAO and the spirit of it and built a set of modular contracts that supports the same sort of functionality while better enabling customization was a fortunate find from our point of view. So once we selected OpenZeppelin to use OpenZeppelin for the DAO, we had to choose our components. And so we have the token itself, which is simply the OpenZeppelin ERC20 contract with the ERC20 votes extension, which is another OpenZeppelin extension that supports assigning delegates and counting votes. It takes snapshots in a way that means that it's possible to see exactly how many votes a particular delegate had at a particular block in the past without adding too much overhead to ordinary token transfers, particularly if the user hasn't delegated to somebody. And to that, we added a couple of custom changes. We added our own Merkle airdrop supports for the airdrop of tokens. The reason we did this as part of the token rather than a separate contract is that we wanted to be able to have users claim their tokens and delegate to somebody in a single transaction rather than either making multiple transactions or having to sign a message and then send another transaction. And this minimized the complexity and the gas costs. And finally, we added an extension to the token for issuance, allowing the DAO to issue up to 2% of the total supply per year once a year, optionally. For the time lock, which is the contract that's effectively in control of all of the DAO's assets and enforces a delay between the putting forward of a past proposal and its execution, we simply use the OpenZeppelin time lock controller without any need for any changes. And then the governor, we use the OpenZeppelin Governor contract. The framework, as Hadrian described, is very modular. It lets you choose different modules for each of the parameters, like how votes are counted, how proposals are passed, how voting is done, and so forth. And even for somebody like myself who's very familiar with smart contract code, this can be initially a little intimidating to select all the right parameters. And I'm slightly embarrassed, slightly proud to admit that I actually used the OpenZeppelin wizard for this. So for both the token and the governor, our starting point was literally just to go to the site and use the wizard to generate a smart contract template, stick that into our hard hat project and start making changes from there, and then building up unit tests on any of the functionality that we'd changed. And so that, that gave us a very solid starting point for the DAO, and we didn't really have to make many changes to the governor after that. One change we did make is that by default, the quorum denominator, so basically the number that the quorum value is divided by, is set to 100 so that the values are percentages. But we've noticed a lot of DAOs function with quorums in the sort of 1 to 5% range, maybe 10% at the extreme. And we wanted more resolution since the numerator can be adjusted at runtime, but not the denominator. So we set that to 10,000 so that we're using basis points, and it gives us a little more flexibility in terms of adjusting the quorum up or down if we need to. So, what future improvements would we ENS like to see to the ENS, to the OpenZeppelin contracts? One is something that I filed as soon as we announced ENS, and I could safely talk about it, announce the DAO, and it has already been acted on and implemented and will be out in the next version. And that's the preventing of attacks with late quorums, where effectively you have to treat every vote on chain as an existential crisis because you never know what somebody might submit in the very last block. Whereas with this change, you can be assured that if it hasn't reached quorum, you don't have to worry about it until it does. And if it does reach quorum, you'll have a minimum of, say, 2 days to respond. We'd love to see more flexible options around vote counting. So allowing, for instance, for the possibility that you want to count votes not just in your own contract, but also have some sort of support for wrap tokens to count LP tokens as votes or stake tokens as votes, or to allow for counting, allowing people to vote even if they've delegated. Some of these are complex problems. And need a lot of study, and maybe the best solution is simply easy overrides to allow for this sort of customization. One thing I think we're definitely going to want to explore in the future, and I know will be fairly easy with OpenZeppelin's modular structure, although there's no current pre-built modules for it, is the possibility of moving the governor itself to an L2 and keeping the time lock on an L1, and then using messaging between the two so that votes can be effectively gas-free, but we can still retain the security of having everyone vote and then execute the changes on L1 where all the contracts live. And support for cancelling votes once they've passed, if, for instance, a quorum is lost, is something that would also be very useful, although substantially less critical with the late quorum attack issue solved. And so that's all I have for you today. I think next, if I'm not mistaken, we're going to Q&A for both of us.
Yeah. Okay, we have a lot of questions already, and just to answer, yes, thank you, Nick, for all these future improvements that you're discussing. Because at OpenZeppelin, we really value the feedback from you, from the community. When people see needs, it's always very interesting. We don't just want to build contract for a community. We want to build contract that the community needs, that we are actually going to be used. So this kind of discussing the module is really something. For the L1, L2, I've seen on the YouTube chat that someone asked for a similar system, that voting that would be gasless and then executing on chain. There are two ways in my mind to do that. One way would be to have some kind of signatures aggregation, some crypto primitives that would allow to do that completely on chain and just have a resolution on chain. Mathematically, it can be done, but it's something we are not really comfortable with for now. Maybe it will be something later, and that would be great. But at the same time, the idea of using these multiple layers that exist with their own security system, and now we have more and more L2 networks that are supposedly having the same security as the L1 network that hosts them. That would be a great thing. So it's something we'll be working on, maybe in the context of the governor, maybe in the broader context of improving the contract framework to do cross contract messaging, because it could just be a simple transaction relayer that the governor could plug onto.
Yes, and I think it may not even require changes for some L2 systems, the ones that are capable of delivering a contract message, you could simply have the governor on L2 have a small smart contract stub that to execute simply calls the L2 to L1 gateway with a call to the governor, to the time lock on L1, which is then relayed, and the time lock treats the gateway contract as being its administrator.
Yeah, these contract stubs are the first thing we want to build as like a primitive, and then builds on top of that, obviously. So I think this is the first question also that we have here that I hope we answered. So the second one is for you, Nick. How does ENS DAO enforce authenticity?
Yeah, so there's a common misconception, which is that people think that if you have, myname.com, you can claim myname.eth inside ENS. And then they naturally raise the question of, well, what if somebody else owns myname.net? But this isn't how it works. ENS allows you to claim myname.com inside ENS. So if you own myname.com, you can set it up inside ENS so that somebody using MetaMask, for instance, can send Ether to myname.com. So they're all separate namespaces. So we don't attempt to enforce any sort of correlation between the owner of a .eth name and the owner of an internet domain with the same name.
Yeah, for the next question, so COMP is an implementation of ERC20 that was, I think, the first one to include this snapshotting mechanism required to secure the voting. I see a question on YouTube about OpenZeppelin ERC20. COMP, just like OpenZeppelin ERC20, are just different implementation of the ERC20 standard. They are all compatible with things like Uniswap, for example. It's just that ERC compound is like I would say monolithic implementation that is designed for voting for compound. We have OpenZeppelin that is more modular and has this vote module. So that's just to explain a bit more about the family of token. If you have a comp token, you have this monolithic contract that does ERC20 well, and that includes all the mechanism needed for voting. This token can be then used by a governor, either by the compound governor Bravos or Alphas, or by OpenZeppelin. So if you have a comp token already deployed, or if you plan to deploy one of these implementations, and you want a governor on top of that, you could go either way. You could go compound governor Bravo, or you could go OpenZeppelin. Obviously, if you go with OpenZeppelin, you might have more options in the long run. I think that's what really was valuable to ENS, having this modularity, this upgradability that you won't necessarily have with Bravo. Bravo is upgradable, but in a much different way. I would say not as easy to use, but obviously I'm biased here. So it all depends on whether you want to have a very simple piece of code and not modify it, then you can possibly go with Compound. Or if you want more options, more modularity, and if you want upgradability, you should possibly go to OpenZeppelin. I think in both cases, you should have a look at the code, try to experiment with yourself, set up test environments, like contract and governor in particular are not very easy to start with. And I would want to say also for Nick, you should not be ashamed of using the wizard. I mean, we don't build it we build it for everybody. And I think I mean, we really value the fact that even an advanced Solidity developer like you find it valuable to just start with the wizard and just continue to customize their code in Hard Hat or in Remix. That's really what we're going for. If it can save you half an hour or an hour, that's an hour that you're spending on something else that's possibly more valuable to the ENS community.
Yeah, and I think it's valuable in that it provides a very easy onboarding process. Like instead of reading through pages of documentation, I can just quickly and visually see which components are required for each bit of functionality.
Also, Solidity 08 has been adding more constraint on how inheritance and override mechanisms work. Sometimes it can be difficult for user to understand these override mechanisms. So the wizard is also here to help them. We have a question about time lock and governance. So this is, I think, an interesting question. Compound designed their governor system to work with the compound time locks. They both go hand in hand. So if you are going the compound way, you are going to get both the governor and the time locks together, unless you start heavily modifying the code. In OpenZeppelin, it's more subtle. Like a governor can just act on itself. You could say that when the vote is over, when we're okay that the quorum was reached, the vote is done, proposal was accepted, let's just run it. That's one way of thinking about governance. Another way is saying that even though it's been voted yes and it's unstoppable, so at some point it will get executed, we still want to add a small delay, and this small delay can be used for users that don't really like the outcome of the vote. In case the vote was really tied until the end, they still have this delay maybe to exit the system. So you don't really need a time lock. I'm not sure if it's advisable or not. I think it's based on how you see your rate profile, and the governance already had a lot of delay in taking actions compared to say multisig. So maybe you'd say that time lock is not really necessary on top of that. For you, Nick, time lock was a no-brainer. You decided to go it out of the box, or was it a discussion?
I think it was probably a no-brainer, because although there's exit is difficult from ENS because of the importance of a unified namespace, some degree of warning is crucial. And I don't think there's a high likelihood of like an evil takeover and somebody doing something really malicious. And in fact, most of the powers have limited scope to do that. But for instance, if the DAO decided to quadruple the cost of name registration, then the time lock delay would give people a chance to extend their registrations at the current price. And I think that's a very fair thing to have in place, especially when the outcome of a vote can swing at the very last moment.
Okay, we have a question about domain ownership, so maybe that's for you.
Yeah, there's no way to establish a connection between two different DNS names in any sort of authentication. We treat them as entirely separate names.
And the next one is about proposals. So I think we will both need to answer this one, because there is a generic way of creating proposals, and then there is a particular ENS case.
Yep.
In the governor, we want to be as unopinionated as possible, and then people can opinionate their implementation by modifying it. So in the base design, that's possibly one of the biggest difference between OpenZeppelin and Compound is that by default, anybody, whoever they are, like even if they don't have any token, can create a proposal, and then the proposal will have to be voted on. That's the base design. Obviously, you can modify it. You can add restriction. You could say that there is a threshold on the number of tokens that someone needs to own to be able to submit a proposal in the first place, but that's an opt-in system. And we could have additional features. You could imagine something that you need to go through proof of humanity to create a proposal, regardless of the number of tokens you have. That's completely customizable. So my answer is, from the OpenZeppelin point of view, we're unopinionated, you do whatever you want, but I'm a bit curious what's ENS point of view to how people are supposed to do proposals.
So in the current deployment, we require 100,000 votes delegated to you in order to create a proposal. And I guess we see it mostly as an anti-spam measure, because every proposal that's submitted needs a serious response. And so we don't want to get into a situation where the DAO is constantly having to vote down things that have obviously little to no chance of passing. I think, with the new quorum module, we could potentially redeploy with a lower threshold. I'd also be interested to see like a module that supports. I've seen some compound style DAOs have support for, I can't remember what they call them, but the basic idea is you can collect signatures from a bunch of smaller delegates to reach the proposal threshold and submit it. So if none of you individually meet the threshold, you can still do it collectively.
And the same question is about how our proposal initiated. So at the core level, a proposal is a transaction that is submitted to the blockchain and that initiates an entire state. So again, at the OpenZeppelin level we're unopinionated, but obviously different projects have different workflow that they're basically going to ask people to do. Possibly you should document your proposal, possibly make a blog post or ask the community about it. But in the end, even if a proposal doesn't go through the correct way, if it's proposed on chain by someone that has the power to do so, then it will have to be answered on chain. And if people oppose it for a reason that it was not formulated in the right way, it will still have to be opposed on chain. The next question is about ERC20 tokens that is not an OpenZeppelin ERC20. So can I govern that? So here there is really, I mean, I see two understanding of governing something. Here, like if the question is my ERC20 token has privileged access, like there is a minting feature or some posability action on it, and this is done by the owners, and you could transfer this ownership to a governor contract so that the governor becomes the actor. No, yeah.
I think if you look at the next question, it's a follow-up and an elaboration on what they mean.
Yeah, so and the idea is that if you have a governor contract, thank you, Nick, for pointing that out. If you have a governor contract, any role that exists on chain that is transferable, like a no-nable contract, an NFT token that means ownership of something, like you could just use the governor the same way that you would use a multi-sig or a smart contract-based wallet like an Argent wallet. Now, just to come back to the first question, if the question is, can I use any ERC20 to use as the number of votes for a governor contract? This question is yes and no. Yes, you could technically do it because you could configure a governor to do that and just read it, but it would be a bad idea because it would be unsafe. And the reason why it would be unsafe is that if you allow anybody to vote with the number of tokens that they currently have in their wallet, then someone could do a flash loan, vote using this flash loan and get tremendous power, or someone could just vote, transfer the token to another wallet and vote again, and that would be bad. So what you need to do is to make sure that whenever there is a vote for a proposal, this uses a snapshot mechanism. And basically what's happening in the governor contract, both Compound and ours, is that at some point, a block number is decided. It could be the block number where the proposal is created, or it could be a certain number of blocks after that to create a delay so that people can still do their delegation. But we have this block that is the start of the voting period, and this is when tokens are considered. And this means that if you do any transfer after that, well, you could transfer your token away, but you would still keep your voting power, or you could get more token, but you would not get any voting power after that time. And this is a feature that is designed in the comp token, so the compound token, and this is also a feature that is present in the ERC20 vote extension. So if you have a token that is not an OpenZeppelin ERC20 with the vote extension, because an OpenZeppelin ERC20 without this vote extension would be no good either. So if it's not an OpenZeppelin with the vote extension, and if it's not compound, then you should probably not use it for governance. Now, what you can do is you can create a wrapper contract where you would deposit your token, and it would create wrapped token. So, like, I would not call it the X token because this sounds like X sushi, but you see the idea. Like, you take your token, you wrap them, and you get a different, like a stake token that you can always unwrap at any point, just like ETH and wrapped ETH. But this would be tokens and wrapped token, and the wrapped token could have this voting mechanism, and so you could do that so that people would be able to vote with your token through staking. And yes, the next question is yes, you could use your governor to govern an ENS registrar. You could use your governor to govern a no-nable contract to govern the gradability of your contracts. You could even have the governor govern its own gradability. I think this is basically what you would want in the end. And yes, governor can do arbitrary transactions, so you can also use them to handle like treasuries in ERC20s. You could have a governor to handle NFTs if that's ever relevant to you. So the next question from Lucas is, I think it's a very good question. I don't know what you think, Nick. Maybe start with the wizard.
I think, the wizard is a good starting point, but there's so many steps to onboard yourself to doing this that I won't say it's impossible to do it yourself if you don't know how to code, but it could be a difficult process, and there's a risk that you miss or mess something up along the way. So I would be quite cautious, and if you can find someone who can help you put it together, then that would be really valuable.
Also, there is the question of the code, but there is also the question of whether it's needed or not. Whenever you want to do something on chain and deploy contract, just make sure you really understand how this entire system works, what the implications are. Don't try to overdo it. Maybe a governor is the right way to do it. Maybe it's not. Maybe you want to go with maybe for some project like, I mean, ENS started with a multi-sig and with other forms of governance, and that was very fine. And now you are doing this transition, but maybe you don't want to start too big too fast also. So make sure you do it at the right moment and you're not shooting yourself in the foot, because the governor, and if you do it on L1 right now, will be expensive. And if you use tokens that are distributed to the community, then you will need the community to be incentivized to contribute and to see the point. Because if you don't achieve your quorum and no action can be taken because your community doesn't contribute, that's not good either. So be careful what you're doing, not just in terms of code, but in terms of community governance.
I'd suggest too, maybe, that if you're just starting out, you might consider just starting with something simple like a Gnosis multisig, and then progressively decentralize towards a more involved mechanism later.
And the good thing is, if you're using OpenZeppelin Defender, you could schedule your operation and your maintenance through a Gnosis safe, and then later on you could add a time lock on top of your Gnosis safe, so that your user, even though you still have all the power, have this time lock feature, and you will still be able to do that through Defender. And then later you could upgrade to a full-fledged governor with the same time lock, and you will still be able to create your maintenance operations through Defender and have your user votes through Sally. So that may be one of the good paths to increase security step by step. So we're almost at the end of the hour, and I'm not sure there is any more question. At least there is not on the forum. So we can have this POAP token. Thank you, Ruichi. So feel free to claim it. And people like collecting these. I sure do. To prove that you attended this workshop. Obviously, you got more than just a POAP. You also get some very good knowledge from Nick on their insight on how to use the governor and how it fits ENS. Thank you, everybody, for attending. Thank you, Nick, for trusting us with this very important part of your application, and for building such an amazing piece of the protocol, I'd say the infrastructure. That's the right way that I would say.
My pleasure.